Okay, so recap a lot of this. Limit as h goes to 0 of this. So what is this? Now notice you're actually not finding the limit. What are you doing? You're trying to see what this is. Notice this is the natural log of something, e, minus 1. Well, e plus h. Well, that means that would be the natural log of x at e. So where's the natural? So that's why that is a. So if we're going to look through the solutions here, so that's just the natural log of x when at this value is e. And then, of course, okay, so 2. What are we looking on in 2? Position here of a spring. How many times does the velocity of the object equal to 0? So we get the velocity, and this is calculator, so we go ahead and punch it in, graph it. How many times between 0 and 4 do we get that? That's it. That's all you got to do. Not what they are, just how many. And if you have an issue, zoom in on that one and see. So function least value. So again, least value, or wait, the least value changes concavity. So f double prime changes signs. Now f double prime equals 0. F double prime changes signs. So f prime, f double prime. Where does it change signs? How do I know this? I punch it in the calculator. Take a look. The least positive, that is. That's what we're meaning, the least positive. So we just, boom, plug it in there. Which of the following is the greatest value of x such that this? Well, plug them in. See which one, okay? And then you end up with this inequality to solve. You could either graph both of them and intersect them, or set it compared to 0 and see where is the greatest in that interval where those two would equal to 0. Either way, and it turns out to be that. So again, here it's a little bit of work on your own. Then you go ahead and done. Differentiable functions. So we got a whole bunch. So a couple of different things we got. So g is the inverse of f. What's g prime of 3? So the inverse of f. So the derivative of the inverse is the reciprocal of the derivative of the other function, of its original. Now, notice the a and the b are different. So this is a range value. So 3 is a range value. F of what gives you 3? Well, it turns out to be f of 6. So what is the reciprocal of f prime of 6? Again, the inverse, the derivative of the inverse, is the reciprocal of the derivative of the function at the other value. Because again, domain for the inverse is the range for f. So the domain of A is the range of f. Range of f, or domain of f, is the range of g. So f of what gives you 3? It turns out to be 6. So continuous function, that means IVT works good. So any place between, so that means f takes up all function values between -1 and 3 in between x equals -3 and 6. Nothing else. We can't guarantee anything else. We don't know. So again, A does not know anything about a specific value. B, first derivative has nothing to do with intermediate value. We're thinking mean value. Here. Now, this looks like it can be because we said f takes on all values in between -1 and 3, but that doesn't mean it can't be outside or greater than 3, less than -1. One is in between there. So the function value is between these two function values, and c then is between those two x values. -1 and 3, and so d was the answer. E, not so good, because these are function values. And we're trying to compare what is c as an x value. So an x value compared to a function value, no good. First derivative. So here's f prime. Where's f increasing? So how do you know what f, if f is increasing, what do you know about the first derivative? Exactly. First derivative is positive. So what do? We've got the first derivative already. All we do is punch it in the calculator. Where is this graph above the x-axis? Again, notice it's only between 0 and 2 inclusively, so we look and see which one it is, and it turned out to be interval, interval for b, which is, interval for b, between there. Ocho. So function is defined by the definite integral. So think of area between that and that. Which of the values attain a relative maximum? So relative maximum occurs when the first derivative of our function f changes from positive to negative. So what's f prime? Use the fundamental theorem of calc part 2. We get this. Graph it. And it changes from positive to negative. Choice number or choice letter A, which is right there. So again, fundamental theorem of calc, plug the upper limit in, derivative of the upper limit. Lower limit's a constant, so it's -0. We're done. That's f prime. Here's a function. Rate, instantaneous rate of change means derivative. Same as the average rate of change, slope. So where is the derivative, f prime, equal to the average rate of change, the slope? So you set, here's your average, your average rate of change, set it equal. Now, being calculator, and notice answers are all decimals, just plug it in. Plug that in the calculator and you get 2.164. Done. Don't try to do anything else. You don't have to solve it by hand. You can, but it's not necessary because calculator. Height reaches its maximum upward velocity. So what time is this velocity? So is the velocity the maximum? Okay, that means we need to maximize velocity. We need to get the first derivative of the velocity. So velocity, v prime, is that equal to 0? Boom, get this. And ended up realizing, let's see here. Yep, it's a maximum velocity. I did test it. Wait. And now I just go ahead and plug that number. Yes, you could use it. You could punch that in, get the full decimal, plug it in for the original h, and there's your height. Now, multiple choice, I may not be testing it because you got plus or minus. You got one option only. So that's really the way you could do that. Okay, so number 11, free response. Read through it. Of course, you've already did. So is the bird gaining weight faster when it weighs 40 grams or slower? So gaining weight faster, it's a rate of the rate it changes. So the rate of, so what's the rate of gaining weight? So this is, B is the weight, here is the rate of gaining. So at 40 pounds, at 70 pounds, which one is it? which rate is faster? For B, rate of change of B is faster. Ding, right there at 40. Okay. And then find the second derivative. So, since our variable is t, so it's 1/5 times 100 minus t, so it's 1/5 times -1 dB dt. So plug in dB dt back in, and we get this. Now, looking here, from 0 to 100 for B, that's going to be a positive value, times a negative is going to be always negative for second derivative, meaning this is going to be concave, or between 20 and 100, I should say, because that's the interval it says. So since that's always less than 0, that's why we set it here. So the function's always, the graph's always going to be concave down. Well, that works fine here, but notice B is the weight, concave up. So there's a change in concavity. Either way you look at it, it's not concave down from 20 to 100 in terms of time. It's concave up one of those places. And then our old favorite, separate, integrate, separate, integrate. Again, 100 minus B, if that's U, you get -1 du is dV. Boom. Plug in our ordered pair, which was 0, 20. Get negative, the opposite of the natural log of 80. Plug it in here, and solve. As long as t is greater than 0, it makes sense. If t is not greater than 0, the bird's going back inside the egg. So, motion, speed of the particle, increasing or decreasing. So, speed, what's the velocity, what's the acceleration at 5.5? Did it again. So that's all we're looking for. What's the speed, what's the velocity, what's the acceleration? They have the same sign, so the speed's increasing. That's all you got to do. Those number, sentence. Done. Don't say anything else. Don't have to. Average velocity of the particle. So average velocity, we have the velocity function. So that's 1 over the interval length times the definite integral of the velocity from 0 to 6. Just type it in. You have to show that. Yes, you possibly could use accelerate. You couldn't use acceleration. You'd have for average velocity. You'd have to integrate that. Anyways, that would be the best way to do it. Total distance. So, does from 0 to 6 does the object change direction? If you're like, I don't know, I don't want to look back at this and try to figure out where it changes direction and go back and forth, you don't have to. Like it shows here, you can use the absolute value of the velocity inside of the integrand when you integrate. Okay, find the position at that time. Okay, so where does it change? So where's the velocity equal to 0? We get 5.1, blah, blah, blah. Turns out it does change from one sign changes signs. So initial condition plus the change in position, 0 to that B value. Just type that in. That's all. Okay, so that's a quick rundown of everything.